Assalamu alaikum students. Once again, I welcome you all to my YouTube video class. Today, we are going to learn a new chapter, that is Specification and Abstraction. Before we get into the topic, let us see what are the things we are going to learn today. Today, you will be learning about algorithms, algorithmic problems, building blocks of algorithms, and algorithm design techniques. Now, let us see the first topic, that is algorithm. An algorithm is a sequence of instructions to accomplish a task or solve a problem. So, algorithm is a step-by-step procedure to complete a task or to solve a problem. Here, sequence means one by one, and the instruction describes an action, what the steps to be performed and how the steps to be performed to solve a problem. An instruction describes an action. So, when the instructions are executed, a process evolves. That is, your process is started which accomplish your intended task, that is, your mentioned task, or it solves the given problem. So, algorithm is a step-by-step procedure to complete a task or to solve a problem. For example, if we want to add two 4-digit numbers, what we will do? First, we will write first 4-digit numbers, then we will write second 4-digit numbers. Then we will start to add. Finally, we will get the solution for that problem. So, this step-by-step procedure or step-by-step instructions to solve a particular problem is called algorithm. We are very much interested in executing our algorithms in a computer, but computer will never execute the algorithms. Instead, a computer can only execute instructions in the programming language. Here, the instructions may be a statement or a command given to a computer to solve a particular problem. We all know that a computer is an electronic machine. So, to make a computer to work, we have to give some instructions to the computer by using some programming languages. Programming languages may be C, C++, Java or Python, anything. Instructions of a computer are also known as statements. So, each commands or statements in a programming language is called as instructions. Ultimately, algorithms must be expressed using statements of a programming language. A problem is specified by given input data to the computer, and also we have to mention the desired output data and a relation between the input and the output data. So, these three things will be specified while giving a problem. So, first one is the input data, and the second one is the desired output, and the third one is relation between the input and output. So, with these three things, the computer will process and produce the result. An algorithm starts execution with the input data and it executes the statements or instructions given and finishes execution with the output data. So, when it finishes execution, the specified relation will be checked between the input and the output data, whether it is satisfied or not. So, only when it is satisfied, the given problem is solved. Otherwise, the given problem is not solved. This is how relation between the input and output data is checked and the computer processes the information. For example, to add two numbers. To add two numbers, we have to follow certain procedures. First, we need two numbers. Here, the two numbers are 2586 and 9237. Now, we will start adding from the rightmost digits of the two numbers. So, while you add, we will get a carry. So, we have to give a carry to the previous digit, that is, next rightmost digit. And again, the same procedures to be used to solve it. So, this is the simple procedure to add two numbers. Algorithmic problems. there are some principles and techniques for constructing algorithm. So algorithm is a step-by-step procedure to solve a particular problem. Already we said that, right? So while constructing algorithm, the user has to follow some principles and some techniques to accomplish a particular task. Then only we will get a desired output. So every problem is algorithmic in nature. To solve those problems, we have to construct an algorithm. Some types of problems can be immediately recognized as algorithmic. Let us see an example. Consider the well-known goat, grass and wolf problem. A farmer wishes to take a goat, a grass bundle and a wolf across a river. However, his boat can take only one of them at a time. So, the farmer needs several trips to cross the river. Moreover, the goat should not be left alone with the grass bundle. In that case, the goat would eat the grass. The same way, the wolf should not be left alone with the goat. In that case, the wolf would eat the goat. Then how can the farmer achieve the task to carry all the three to the other side of the river? Initially, we assume that all the four at the same side of the river, and finally all the four must be in the opposite side. This is the ultimate aim, to carry all these three without affecting each other to the other side of the river. The farmer must be in the boat when crossing the river, and he has to take any one along with him. So this is the condition here. So the solution to the problem is the set of instructions, the sequence of instructions has to be repeated again and again to achieve this task. So to indicating that who or what should cross the river, like that it will have some basic set of instructions, then only all the three can be carried to the other side of the river. So this is an algorithmic problem. For example, the instructions may be like let the farmer cross the wolf. This is an instruction. Or the let the farmer cross alone. So like this, some set of instructions will be given. So based on that certain set of instructions only, this task will be achieved. Now let us see another example. Consider the chameleons of Chromeland problem. On the island of Chromeland, there are three different types of chameleons: red chameleons, green chameleons and blue chameleons. Whenever two chameleons of different colors meet each other, they both change color to the third one. For example, if the red and green color chameleon are meeting each other, means they will change the color as the blue color, that is the third one. In the same way, if the green and blue color chameleons meeting each other, they will change the color as a red, that is the third one. Likewise, the meeting of each chameleon occurs. Now the question is, for which number of red, green and blue chameleons is it possible to arrange a series of meetings that result in all the chameleons displaying the same color? So this is an algorithmic problem because there is an algorithm to arrange meetings between chameleons. So there is certain number of steps to be followed again and again to accomplish a task. Then only all the chameleons will be displayed at the same color. So we have to use some properties or some techniques of the algorithm. Then only we can find out for which initial number of chameleons the goal is possible. So how many number of meetings should be gathered. Then only the result can be achieved. So these two are the best examples of algorithmic problems. Next, we are going to see about the building blocks of algorithm. So, what are all the basic components are required to construct an algorithm? The basic components are data, variables, control flow and function. Now, let us see the first one, data. We all know that data is a raw fact which is used to process and produce the information, that is, produce the output here. So, algorithms take input data, process the data and produce output data. So, the user has to give data as input. The computer processes the data based on the certain set of instructions and it produces an information, that is meaningful information, as an output. Computers provide instructions to perform operations on data. For example, the computer can do all types of arithmetic operations on numbers such as addition, subtraction, multiplication and division. So, there are different kinds of data such as numbers and text. For example, while adding two numbers, here the numbers are the data. So, based on the given instructions, the computer processes the data and produces the desired output. Next one is variables. Variables are named boxes for storing data. So, variable is a storage location. Using variables, we can store the data. When we do operations on data, we need to store the results in variables. For example, while we are adding two numbers or subtracting two numbers, we have to store the result in a variable. For example, A is equal to 5. 5 is a value or data and A is a variable. So, variables are otherwise known as identifiers, that is identity. The value 5 is stored in a variable A. So, now what is the value of A? 5. The value of A is 5. So, variables are named boxes for storing data. The data stored in a variables is also known as the value of the variable. We can store a value in a variable or we can change the value of a variable using an assignment statement. Here in this example, what is the assignment statement? Is equal to A is equal to 5. A is a variable, is equal to is the assignment statement and 5 is the value or data. We can easily change the value of the variable. Now the value of A is 5. In the next statement, A is equal to A plus 5. The value of A is 5. So, 5 plus 5 is 10. Now, what is the value of A? The value of A is 10. Okay. So, we can store a value in a variable or change the value of the variable using an assignment operator. Is equal to is an assignment operator. Using this, we can change the value of the variable. Computational processes in the real world have state. So, state is the computational process. As a process evolves, the state changes. So, as I said previously, the value of A is 5. Then we have changed the values of the variable as A is equal to A plus 5. Now the value is A is equal to 10. So, as a process evolves, when we process the input, when we process the value, the state changes. So, how do we represent the state of a process and the change of a state in algorithm? The answer is the state of a process can be represented by a set of variables in an algorithm. So, every program needs some input data to process and produce the output. So, data are stored in a set of variables. While processing, the values of the variables will change. So, as the values of the variables are changed, the state changes. The best example of state is traffic signal. A traffic signal may be in one of the three states, that is green, amber or red. So, these three colors are considered as states here. The state is changed when the color of the signal is changed to allow a smooth flow of traffic. The state may be represented by a single variable called signal. Okay, we are using a single variable that is called signal. The name of the variable is signal and the three input values are green, amber or red. Green represent go, amber represent get ready and red represent stop. So, when the values of the variable is changed, automatically the state also changed here. Next one is control flow. An algorithm is a sequence of statements. Sequence means one by one. Okay. An algorithm is a sequence of statements. However, after executing a statement, the next statement executed need not be the next statement in the algorithm, which means statements in a program need not necessarily be executed in a sequential order. Some programs will be executed one by one, that is in a sequential order. Some statements in a program need not be executed in a sequential order. Some segments in a program are executed based on the condition of a program. In such situations, the flow of control jumps from one part of the program to another, that is called control flow. We have three different types of control flow. They are sequential control flow, alternative control flow, and iterative control flow. First one is sequential control flow. Sequential control flow is nothing but the statement will be executed one by one after another in the same order. That is called sequential control flow. Okay, a sequence of statements are executed one after another in the same order as they are written. That is called sequential control flow. The second one is alternative control flow. Here, the condition of the statement will be tested first. If the condition is true, the statement will be executed. In case if the condition is false, an alternative statement will be executed. So, alternative statement is like if-else statement. If the condition is true, true block will be executed. If the condition is false, the true block will be skipped and the alternative statement, that is else block, will be executed. This is called alternative statement. Next one is iterative control flow. Iterative is nothing but loop. Here also the same, a condition of statement is tested first. If the condition is true, a statement is executed. So, iterative control flow means it executes a set of instructions repeatedly for a certain number of times, which means the same process will be repeated until the condition becomes false. This is called iterative control flow. And the last one is functions. Algorithms can become very complex. The variables of an algorithm and dependencies among the variables may be too many. For example, if we are constructing an algorithm for a small program, means it is very easy. In the same way, if we are constructing an algorithm for a huge program, means it is little bit tough. Why? Because we will use many variables in the program. Then it is difficult to build algorithms correctly. In such cases, in such situations, we have to break an algorithm into several parts. Then we have to construct each part separately. And then we have to integrate. Integrate means join. We have to join all the parts to complete the algorithm. Then each part of an algorithm are known as functions. So the parts of an algorithm are known as function. Okay, the huge algorithm will be separated into small groups. Then each part of an algorithm are known as function. A function is like a sub-algorithm. A function is nothing but a sub-algorithm. Okay, it takes an input and it produces an output, and also it satisfying an desired input-output relation. So, function is like a sub-algorithm. Okay, algorithm needs an input, it processes the input and it produces the desired output, and also it satisfies the input-output relation. For example, an algorithm consists of 4 different types of function, means each function must satisfy the input-output relation. Now, let us see an example. If we want to calculate a surface area of a cylinder of radius r and height h. So, to do this, we have the formula, that is A is equal to 2 pi r square plus 2 pi r h. Here we are using 2 formulas, one for area of circle and another one is circumference of a circle. So, we have created 2 functions here, one for area of circle, that is circle underscore area of r, that is one function. Then another function is circle underscore circumference of r. So these two are functions. If we are combining these two functions, if we are adding these two functions, we will get the solution of area of cylinder. Now we will move on to the next topic, that is algorithm design techniques. There are a few basic principles and techniques for designing algorithms. They are specification, abstraction, composition and decomposition. In this chapter, we will discuss first two, that is specification and abstractions, and the next chapter, that is chapter 7, we will be discussing about the composition and decomposition. So, first we will see specification. The first step in problem solving is to state the problem precisely. So, to solve a problem, first we must state the problem clearly and precisely. Precisely in the sense, we have to specify the problem shortly and exactly. A problem is specified in terms of the input given and the output desired. So, while analyzing the problem itself, we can able to identify what are all the inputs are required and what is our desired output. The specification must also state the properties of the given input and the relation between the input and the output. So, in first step, we have to analyze the problem and we have to specify, that is, we have to state the properties of the input. Based on the property, we have to find the relation between the input and output. So, that is the solution of the problem. The relation between the input and output is the solution of the problem. So, specification of an algorithm is the desired input-output relation. Next one is abstraction. A problem can involve a lot of details. So, several of these details are unnecessary for solving the problem. Only a few details are essential. So, ignoring or hiding unnecessary details and modeling an entity only by its essential properties is known as abstraction. For example, when you press a key on your keyboard, the character appears on the screen. You need to know only this, but how exactly it works electronically is not needed. So, this is the best example of abstraction. So, what is the meaning of abstraction? The process of ignoring or hiding unnecessary details and modeling an entity only by its essential properties is known as abstraction. The next one is composition. An algorithm is composed of assignment and control flow statement. Already we have learned control flow statement, right? A statement in a program need not necessarily be executed in a sequential order. Some segments in a program are executed based on a condition. In such a situation, the flow of control jumps from one part of the program to another. That is called control flow. So, the control flow means the order of execution of statement. So, there are three types of control flow statement: sequential control flow, alternative control flow and iterative control flow. The last one is decomposition. We divide the main algorithm into function. We have already learned function, right? Function is nothing but sub-algorithm. So, decomposition will divide the main algorithm into function. Then we construct each function independently of the main algorithm and other functions. For example, if we are creating 4 functions, means the 4 functions are independent and they do not have any connectivity within each other, and they do not correlate with the main algorithm. Only thing is, at the end, all this will be combined to form a single algorithm. So, for all these 4 functions, we will give separate input and we will get the desired output. Finally, we construct the main algorithm using the functions. When we use the function, it is enough to know the specification of the function. It is not necessary to know how the function is implemented. So, decomposition breaks down a problem into smaller sub-problems and combine their solutions to solve the original problem. Now, we will discuss about the detailed concept of specification. Already we have learned specification, right? So to solve a problem, first we must state the problem clearly and precisely. Okay, the first step in problem solving is to state the problem precisely. Precisely in the sense in shortly and exactly. We have to state the problem. Then a problem is specified by the given input and the desired output. So while analyzing the problem itself, we can able to identify what are the inputs are required and what is our desired output. So, to design an algorithm for solving a problem, we should know the properties of the given input and the properties of the desired output. So, while designing an algorithm, the user should know the properties of given input and the user should know the properties of the desired output. So, the goal of the algorithm is to establish the relation between the input and the desired output. So, in first step, we have to analyze the problem and we have to specify that we have to state the properties of the input. Based on the properties, we have to find the relation between the input and output. So, that is the solution of the problem. An algorithm is specified by the properties of the given input and the relation between the input and the desired output. So, while constructing an algorithm, the user has to specify the properties of given input, output and the relation between the input and output. In simple words, specification of an algorithm is the desired input-output relations. The inputs and outputs are passed between an algorithm and the user through variables. So, the user has to give the values to an algorithm through variables. So variables, what is meant by variables? Variables is nothing but the container which holds the values. So all the values will be stored in the variables. Okay. The values of the variables when the algorithm starts is known as the initial state and the values of the variables when the algorithm finishes is known as the final state. So already we have learnt variables, right? Variables is the storage location. All the inputs and output values will be stored in that place. So, the values of the variables when the algorithm start is known as initial state. The same way, the values of the variables when the algorithm finishes is known as final state. Now, let's see an example. Let P be the required property of the inputs and Q be the property of the desired outputs. Then the algorithm S is specified as. So, how to write the specification for algorithm? First step, algorithm underscore name of inputs. First statement, we have to mention the name of the algorithm. So, this line indicates the name of the algorithm. The second step, we have to mention the property of an input, that is double dash inputs colon P. Here a double dash indicates that the rest of the line is a comment. So comment is nothing but a statement which are used to annotate a program for the human readers and not executed by the computer. So comment gives the annotation to the user. Double dash indicates that this statement is understandable only by the user and this comment will not be executed by the computer. So, in second statement, we have to mention the property of the input. Here, P is nothing but the property of the given input. And the third statement, double hyphen outputs Q. Here, the double hyphen outputs is a comment line which will be understood only by the user, which will not be executed by the computer. Here, the output property is Q. So what is specification? Specification means if the algorithm starts with the inputs satisfying P, then it will finish with the output satisfying Q. So how to write the specification for the algorithm? We have to use 3 steps. The first step, we have to mention the name of the algorithm. In the second step, we have to mention the property of the input. Then third step, we have to mention the property of the output. So this is how we have to write the specification for algorithm. Let's see an example. Write the specification of an algorithm to compute the quotient and remainder after dividing an integer a by another integer b. For example, divide 22, 5. If we divide 22, 5, what will be the answer? 5 4s are 20. So 4 is the quotient and 2 is the remainder. In the same way, if we divide 15 by 3, what will be the answer? 3 5s are 15. So 5 is the quotient and we have no remainder. So 0 is the remainder. So for this, we are going to write the specification. Let a and b be the input variables. So, input variables are a and b. So, we will store the quotient in a variable q and the remainder in a variable r. So, we are using two variables q and r. So, q and r are the output variables. Are you understanding that? So, a and b are the two input variables. One is dividend and another one is divisor. The next two, q and r, are the two output variables. One is quotient and another one is remainder. Now we are going to solve this. What are the properties of the inputs a and b? In specification, we have to specify the properties of inputs, properties of desired outputs and the relation between them. So, what are the properties here? A should be an integer because the problem is we are going to divide two integers. Integer means the whole numbers without using decimal point. So, the remainder is meaningful only for integer division. And the second input property, b should not be 0 since division by 0 is not allowed. Okay, why? Because if we divide any number by 0, the result also 0. So, b should not be 0. So, the property of input is a should be an integer and b should not be 0. So, based on this, we are going to specify the input properties here. Double dash inputs colon a is an integer and b is not equal to 0. So, this is how we have to specify the properties of the input. Next, we have to specify the relation between the inputs and desired outputs. So, what is the desired relation between the inputs A and B and the desired outputs Q and R? Here, we have to mention the input property and the output property. The two outputs Q quotient and R remainder should satisfy the property. So, what is the property here? E is equal to Q into B plus R. So, Q is the quotient and B is the divisor and R is the remainder. So, when you multiply quotient into divisor and you add with the remainder, you will get the dividend A. Okay. So, 22 divided by 5, that is 5 4s are 20. So, 4 is the quotient and 2 is the remainder. So, Q into B, that is 4. Q quotient is 4 here and the divisor is 5 and the remainder is 2. So, 4 into 5 is 20. So, you have to add with the remainder. So, 20 plus 2 is 22. So, this is the relation here. And the next statement, the remainder R should be less than the divisor P. So, we all know that always the remainder should be less than the divisor B. So, the property is 0 is less than or equal to R, then less than B. So, the remainder R should be greater than 0 and less than the divisor. So, when we combining these two statements, these two properties, we will specify the desired input-output relations. Now, the output property is double dash outputs colon E is equal to Q into B plus R and 0 is less than or equal to R, then less than B. So, this is the specification of output property here. Now, we are going to write the entire specification of the algorithm. The algorithm consists of 3 steps. First step, specify the name of the algorithm and the inputs. So, the name of the algorithm here is divide and A and B are 2 input variables. And the second step, specify the property of the input variables. So the input property is double dash inputs colon a is an integer and b is not equal to 0. So this is the input property. And the third step is an output property. It specifies the desired input-output relation. So the output property is double dash outputs colon a is equal to quotient into divisor plus remainder. That is a is equal to q into b plus r, and 0 is less than or equal to r, then less than b. So this is the entire specification of an algorithm. Next one is specification format. We can write the specification in a standard 3-part format. Just now we have seen how to write the specification of an algorithm. It consists of 3 steps. The first step is we have to mention the name of the algorithm and the input variables. Okay, the name of the algorithm and the inputs. And the second step is we have to specify we have to mention the property of the input variables. And the third step is we have to mention the property of the output, and also we have to mention the desired input-output relation. So, the first part is the name of the algorithm and the inputs, and the second part is the property of the inputs. It is written as a command which start with double dash inputs. Okay, and the third part is the desired input-output relation. It is written as a command which start with double dash outputs. So, the input and output can be written using English and mathematical notation. So this is how we have to write the specification of an algorithm. Students, the first part of this lesson ends here. The remaining topics will see you in the next video class. And today's assignment is define an algorithm, distinguish between an algorithm and a process, and what is the format of the specification of an algorithm. Submit your assignments on time. Thank you for watching this video. We'll see you in the next video class. Assalamu alaikum.